Welcome back, everyone. Today, we're diving headfirst into a topic that you might not expect.
Yeah, it's a bit of a strange one.
It is, yeah. But it's super fascinating. We're going to be looking at quantum mechanics.
Through the lens of the Trump administration.
Right. I mean, it sounds crazy, but honestly, some of the sources we found, they use these really out there Trump analogies to try to explain, some of these really complicated quantum physics concepts.
Which is surprisingly pretty effective.
Yeah. I mean, you wouldn't think it would work,
No.
but it kind of does.
It really does.
Yeah. So we're going to use that as a jumping off point. We'll talk about superposition and entanglement and quantum leaps and all that.
But, we'll also look at what Trump actually did in the field of quantum mechanics.
Exactly.
Because it goes beyond just the analogies. There were some concrete actions taken.
Yeah, for sure. So where should we start? I mean, do you want to just jump right into these crazy analogies?
Let's do it.
Okay. All right. So one of the first things I came across was this idea of using a Trump rally to explain superposition. Have you seen this?
Oh, yeah, I remember that one. It's like, imagine a Trump supporter at a rally in Florida,
Right.
cheering, waving a flag. But at the same time, they're also, on Twitter.
From New York.
From New York, yeah, firing off tweets.
And it's like they're in both places at once.
Exactly.
Which, I mean, obviously that's not possible in the real world.
No, not for us regular folks.
No, but in the quantum world, that's kind of how particles behave.
Right.
Right.
Right. It's like they can exist in multiple states at the same time. It's not until you try to measure them
Okay.
that they choose one state.
That makes it more complicated.
Yeah. So, I mean, obviously it's a silly analogy.
It is.
But it does a pretty decent job of illustrating that core concept of superposition.
Yeah, I think so too. Okay, so what about entanglement? Because that one always trips me up. It's like, how can two particles be connected,
Yeah,
even when they're miles apart?
I know. This one's really hard to wrap your head around.
It is.
But they have this analogy about Trump's tweets.
Oh, yeah, I remember this one.
Remember how one tweet could instantly send the stock market into a frenzy?
Oh, yeah, like total chaos.
Yeah.
Yeah.
So they're comparing that to entangled particles. No matter how far apart these particles are, they're somehow linked. So if you do something to one particle,
The other one reacts immediately.
it's mind-blowing.
It is mind-blowing. So Trump's tweets are basically entangled particles.
In a way, yeah. It's a weird way to think about it.
It is a weird way to think about it, but I kind of see what they're getting at.
Right. It gets the point across, even if it feels a little absurd.
Right. Okay, so then there's quantum leaps, right?
Yeah.
The jumps between energy levels.
Yeah.
And they compared that to, what was it, the policy shifts in the Trump administration?
Yeah, because, one day it would be one thing, the next day something completely different.
And you never saw it coming.
Totally unpredictable. Just like those sudden jumps in the quantum world.
So is that how we should be picturing these quantum leaps? Are they really that abrupt?
Well, that's the thing about quantum mechanics. It often defies our everyday intuition. These leaps are real, but they happen on a scale so tiny that it's hard to even imagine.
Okay, so we've got these really out there analogies,
Mhm.
but Trump's involvement with quantum mechanics goes beyond just these metaphors, right?
Oh, absolutely. I mean, he actually signed the National Quantum Initiative Act back in 2018.
Right, which, I mean, that's a pretty big deal.
Huge deal. It was a bipartisan effort to invest over $1.2 billion into quantum technology development.
Well,
Yeah, it shows that there was a genuine understanding in Washington about the importance of this field.
so what did this initiative actually look like in practice?
Well, one of the key things was the creation of these quantum research hubs.
Okay, so where were these hubs?
Well, they were set up at some pretty prestigious institutions. You had NIST, the National Institute of Standards and Technology.
The Department of Energy, the DOE,
Right.
and the National Science Foundation, the NSF.
So these hubs, I mean, what were they actually doing? What was their goal?
Their main focus was on research and development. They were trying to push the boundaries of quantum information science.
So, a lot of people, when they hear quantum, they think of computing. That's the big thing.
Right.
Was that the main focus of this initiative, or were they looking at other areas too?
It was definitely a big part of it, but they were also exploring other areas, like quantum communication, quantum sensing, quantum materials.
So what's the potential impact of all this? I mean, why should we even care about quantum mechanics?
Well, the potential is enormous. We're talking about breakthroughs that could completely transform industries.
Give me an example.
Okay, so imagine unbreakable encryption for our data.
That would be huge.
Right.
Yeah.
Or super fast drug discovery, leading to new cures for diseases.
Okay.
Or materials with properties that we haven't even dreamt of yet. Wow. That's a lot to take in.
Yeah, the possibilities are pretty mind-blowing.
So, I mean, it sounds like this initiative was a success then.
It's definitely too early to say for sure, but there were some promising signs. For example, some quantum computing companies saw their stock prices surge after the act was passed.
Oh, really? So like a quantum leap in the market.
Exactly. It's like investors were suddenly realizing the potential of this technology. And there was even talk of appointing a quantum czar in the White House.
Oh, wow. A quantum czar.
Yeah.
That's wild. So what would a quantum czar even do?
Well, the idea was to have someone who could really champion quantum technology, make sure the U.S. stays ahead of the curve in this global quantum race.
So it's fascinating to see how these abstract quantum concepts, which we just explored through these crazy Trump analogies, are actually tied to real-world initiatives with such huge implications.
It really is. And it makes you wonder, now that Trump's been elected for a second term, will he continue to make quantum technology a priority?
Right, because that's a big question.
It is. And what about this quantum czar? Will that actually happen? And if so, what kind of impact will they have?
It's a lot to think about.
It is. But it's definitely worth paying attention to.
So, to everyone listening, we've just scratched the surface here.
Mm-hmm.
If you're intrigued, I urge you to dig deeper. There's a whole quantum world out there waiting to be explored.
Absolutely.
And who knows, maybe in a few years we'll be doing another deep dive into this topic.
Yeah.
And see how things have evolved.
Definitely.
All right, that's it for today. Thanks for listening.
Thanks, everyone.